Good morning, children. I welcome you all to today's session of science. We are on to chemistry, and the chapter is atoms and molecules. And we have seen about the various laws of chemical combination and the Dalton atomic theory and the modern atomic theory. And now we will be studying about atom, right? Visit any construction site, you will see bricks are used to make walls. Walls delimit rooms, and rooms collectively form building. Similarly, an ant hill sand is the basic constituent, right? The basic unit which forms the building or ant hill are the building blocks. As you have seen in the above example, bricks are the building blocks of building, and sand is the building block of an ant hill. Similarly, the building block of all the matters are atoms. The term atom was first used by John Dalton to describe the ultimate particles which constitute the matter. Right? According to him, atom was the smallest particle or element and is the unit of chemical reactions. Right? And this is what the Dalton said, that it is the unit of the chemical reactions. It may or may not have an independent existence. Atoms are very small, they are smaller than anything we can imagine. Many millions of atoms stacked together would make a layer as thick as a sheet of paper. Now see, these are the some sizes given: atom of hydrogen, molecule of water, and all that. Now let us see the symbol of atom of different element. It practice of representing different things by using symbol is very old. More than 1,000 years back, alchemists in Egypt used the imaginary figures of planets to represent metals alloys. For example, gold was represented by sun, silver by moon, iron by Saturn, etc. You can see here in this figure here that all the different metals are represented by symbols, and these symbols are of some planets, right? Subsequently, John Dalton in 1808 represented various elements by making different marks inside a circle, which he used a symbol for an element. He also meant a definite quantity of element, that is one atom of that element. You can see here in this chart this various atoms and their symbols, right? See here, children, in this one, right? Okay. Now what happened later on was Berzelius was a scientist who represented these elements by some letters, right? Firstly, what he did, he presented some elements by the first letter of their spelling. Like say carbon, the first letter is C, so the symbol is C. Hydrogen H, nitrogen N, oxygen O, sulfur S, boron B. When names of two or more elements began with the same letter, then what he did was he used the first two letter, like calcium Ca, cobalt Co, cadmium Cd, chlorine Cl, neon Ne, nickel Ni, right? Barium Ba. You can see it from this chart here, children, that whenever the names were common, the first letter was common, he used the second letter also. In many cases, the symbol is derived from the Latin name of the element, right? Gold Latin name is aurum, silver is argentinum, right? Mercury is hygerium, right? This is super duper important because the names are not common. They have got nothing to do with the spelling of these elements, right? Rather than it is the Latin name which you need to remember. Thus the abbreviations used to express the names of the elements are known as symbols. Symbols of elements represent the following factors. They represent the name in the short, represent the one atom of that element. Symbol of an element represents the quantity, right? Now this is a table of some of the elements which you need to practice. Next we see is what is atomic mass. As atom is the smallest particle uh, and is the unit of chemical reaction, it may or may not have an independent existence. So you can see here the atomic weight or mass of an element can be defined as the number which indicates how many times the weight of one atom of an element is heavier than weight of one atom of hydrogen, right? Okay. Now it was seen later on, founded out that carbon was used for this atomic mass of an element. See, children, I am referring to this point here. Right. See here, the definition is atomic mass of an element is the times of in which its mass of the element is divided when divided 1/12 part of the mass of one atom of the carbon, right? That is the atomic mass of the element. Okay. Now on the basis of that, some of the atomic masses which you need to memorize by heart is given in this table, right? You need to memorize these. An atomic mass unit is being written as AMUs. Now we come to the term molecule, which was first described by Avogadro to describe the smallest particle of matter, which is capable of existing independently, right? Type C, like example Cl2, H2, and H2, H2O. Now first is types of molecule. First is homoatomic molecule. Now homoatomic molecule is formed by combining similar atoms, like similar atoms. See, for example, here these are the homoatomic molecules in this, right? Mono, in this also there are 3-4 types. First is HENEKR are also called monatomic molecules, right? And then diatomic is O2N2Cl2, right? And then ozone is triatomic, right? So monatomic is He, helium, neon, argon, krypton, like all the inert gases are monatomic. Diatomic are all the gases, oxygen, nitrogen, hydrogen, chlorine, and ozone is triatomic, right, children? Now we come to the difference between an atom and molecule. So atom is the smallest particle of an element which generally cannot exist in free state, whereas molecule can exist in free state. An atom does not get decomposed in a chemical reaction, molecule decomposes. An atom is made up of fundamental particle, electron, proton, neutron. Molecule is made of atoms of similar or different element. Right? Now these are some molecules. Carbon dioxide, in which carbon and oxygen are in the ratio 3:8. Now, how is this 3:8, children? Right? Because see, it is, let me state, it is CO2, right? So, C is how much? 6. And O2 is 8 into 2 is equal to 16. Right? So, if we do CO, the ratio between C and O will be is equal to 6 by 16. So that is 2 3 is a 6 and 2 8 is a 16. So the ratio is 3 is to 18. Sorry, 3 is to 8. Right, 3 is to 8. Okay. This is how all of them are calculated. Now ions, compounds composed of metal and non-metal contain charged species. These species are known as ions. Ions are formed from neutral atoms by gain or loss of electrons, loss of one or more electrons, right? So this is, there is a polyatomic ion also. A group of atoms containing charge is known as polyatomic ion. Now NH4, see all these are ions, and it is these ions which actually take part in a reaction. Atom has no charge over it. Ion has a positive or negative charge over it. Atom, when gets or loses electron, becomes an ion. Ion, when gets or loses electrons, becomes an atom. Cations are smaller, anions are larger. Respective atoms will be smaller than anion and larger than cations. Atoms are combined to form even in solid state. Ions are possible only in liquid state. And atoms are all alike. Ions may be cation or anion. And see, this is how they are written for sodium Na plus. Right? So there are some elements which show more than one valency, right? Like calcium is there, and the others, right? And now we are into the formula formation, right? You can see here NaCl, the valency is 1 1, and we cross it, and the formula becomes NaCl. See, children, this is how the formation of formula occurs. You can see it here. Similarly, for other elements, CCl4, carbon has 4 valency and chlorine 1, and the 4 valency of carbon makes it Cl4, and the 1 valency of chlorine makes it C. Right? Now we come to molecular mass. The term molecule was first used by Avogadro to describe the smallest particle of matter which is capable of existing independently. Now, molecular mass is the mass of one molecule of the substance upon 1/12 the mass of one atom of carbon, right? Now, these are a few numericals here, right? This is how unit mass is calculated for NaCl. Na, the atomic mass of Na is 23 and the Cl is 35.5, right? We write and we add it. CCl2 here, you can see in this one, right? See the atomic mass of carbon plus 2 into atomic mass of chlorine, because there are two atoms of chlorine, right? So 40 plus 2 into 35.5 is equal to 111 U, right? Okay. So I think we should stop here. I hope you enjoyed it as much as I did in making it. And until we meet again, it's a goodbye.